Hello.
Well, how's everyone doing?
I'm doing well. How are you?
Yeah, pretty good.
Nice to see you, Prateek. Was just in the comments in your doc.
Sorry, what?
I was just in the comments in your doc. I was before the meeting. I was reviewing
Yeah.
all the discussions happening.
Okay. Okay.
So, hello, everyone. While um, while we're waiting for everybody to join, we'll do our usual. I pasted in the chat the link to the notes doc. So please add yourself through list of attendees, who you are, who you're working for, if you wish to share, and what you would like to talk about today. And we'll build the agenda on this. And then I'll do my best to manage time for the remainder of the meeting. And if you just want to listen in and be a fly on the wall, that's totally okay. But please don't hesitate if you have things like a PR that needs attention, a spec that needs approval, or have a question. This is the time to do it. So if you just join, the agenda is in the chat, the link to the agenda. Okay, seems to have a relatively smaller meeting today. I think there's a conference going on. Thanks for all who are here. Now there's still some typing happening. Yeah. Okay, it looks like we have an agenda. So first, before we start talking about the topic, I wanted to make a short announcement. I'm going to send an email to the mailing list, but we elected Andrew Lamb as a new PMC member, so congrats to him. And unfortunately, he's not here today. I think there's the conference going on. But I'll send another email to congratulate him on the list, and we can all pile on if we wish to. So first topic, I think there's been a bunch of progress on the ALP spec, and we want to make an update and see, what else needs to be finalized there. Go ahead, Prateek.
Hi. I'm gonna paste the link just in case people don't have the link.
Oh yeah, let me stop sharing so you can share your screen.
Okay.
Go ahead.
Let's see if I can find the window. Yeah. ALP spec. So I just need. Okay, what do you guys see? Okay, I see it over here. So I have, I want to share a different window, but
Oh, did he close the window, the wrong window? Uh-oh. Welcome back. You're on mute.
I think you're muted.
sorry, Julian, if you can share that specific document, which is the spec document. So what we have right now, Julian, can you share that?
Yes.
Okay. So from the specs perspective, we've written out a spec which closely resembles what was proposed in the paper. And it handles both the floating and double point columns. From the initial spec, so this specific spec, as we initially discussed, handles the ALP pseudodecimal case. And with the ALP pseudodecimal handling, we have also published, the benchmarking numbers and the PR that we have implemented in the Arrow C++ code base. And the numbers along with it, which I'm going to send a link again on the chat now. So at the current standpoint, based on at the current point, after the spec was published, there was a lot of feedback from Andrew Lamb, Micah, and a few other folks. And with that iteration, what we have done is we made improvements to the headers that we maintain. So the headers are like a lot more compact after the feedback. The ALP header sitting at just 8 bytes. And we have the flexibility to have different kinds of encodings for the integer values in future. So right now it's based out of an enum, which right now is set to bit packing or for encoding the data. And we also have enums to arrive at future flexibility in terms of handling like real double values. Or one of the feedback from Azim, the author of ALP encoding, was try and extract just the first 2 bytes and just compress them using Z standard. So the spec at this point, the headers and the metadata have been made super compact. They provide enough flexibility to add, different and faster encodings for the data. Alongside that, one of the things that we have done to the spec is the entirety of the meta now sits towards the start of everything. So the benefit that it provides is you will be able to jump to a given value with very minimal time. So far, for most of the encodings, we have to, decipher the metadata, jump to a value, then decipher a part of the metadata, and then jump to a value. Everything now is very compact and sits towards the start. So that allows you to jump to a given set of values. So not just analytical workloads, more of a hybrid OLTP workloads will also benefit with this layout. So take a look at that, at this thing, and if you have any further suggestions. But right now, I think there's been a very active discussion, and the doc has evolved a lot over the last 2 weeks with incorporating the feedback. One of the questions from, I think, Gang Wu and Antoine Petro on the mailing list and on the document was also if they can easily reproduce the data. So this is I think the thing that Julian's sharing right now, the page layout. You have the header, you have all the metadata that sits in the start, then you have data array data towards the end. And Antoine wanted to reproduce. So in that second document that I just shared on that message list, we have just the numbers that he was interested in terms of ALP and byte stream split with Z standard and byte stream split with the LZ4. In those cases, ALP for pseudodecimal is a strict winner. For the cases where byte stream split plus LZ4 tends to do better in terms of decompression speed, it performs 2x worse in the compression ratio than ALP. And a lot of the data sets are such that ALP does a lot better in terms of compression ratio, but is lagging behind byte stream split plus LZ4 in terms of decompression speed by 10%. But based on the numbers that we have internally, it's very easy to bridge that gap and far exceed the performance of ALP with improvements to bit unpacking. So as we work towards that sometime this year, ALP will stand much better in terms of compression ratio and decompression speed compared to any other alternative that we have in Parquet. So yeah, at this point, the spec has evolved a lot. We've ironed out a lot of the things in terms of better expressibility, flexibility, random seeks, and we have a PR which anyone can run on their machine to get the numbers for. And here is the doc to just have the numbers that I calculated on Graviton 3 machine. On Graviton 4, if you run it today, you will have ALP doing a lot better than byte stream split. Somehow byte stream split doesn't improve a lot with the Graviton 4 processor. I don't know why. So I strongly feel it might be related to maybe a little better memory bandwidth or larger L1 cache. So that's it. Any questions that the question that I have for the Alkis?
Is the byte stream split implementation vectorized for
whatever we have in ROC plus, whatever we have in ROC plus repository, the OSS repository?
Does anyone know here? I didn't look at that.
I know there was a vectorized implementation. I'm not sure if it's using x86 intrinsic specifically, or if it was like ported to XMD. I would need to double check, but there is a vectorized implementation. I just don't know if it would affect ARM or not.
Okay. Thanks.
I think with respect to SIMDization, I think if you do that, the same benefit's going to be applied to the LP part also. With the byte stream split, I think the bottleneck becomes not byte stream split, but the Z standard. Like if you just do byte stream split, no compression, of course, but that's not what breaks the decompression speed. The decompression speed it's bottlenecked by the Z standard decompression speed. And over here, Z standard is Z standard level 1. As soon as we start going to 3 and 4 for better compression ratio, the decompression speed drops exactly by half. So I think one of the comments from we looked at the implementation, entropy encoding is what's missing in Z standard level 1. As in, we've done enough and varied testing with, I think, 25 data sets at this point. Data sets coming in from papers, data sets coming in from the ALB paper, data sets coming in from what was suggested by, I think, Micah and Andrew. There is like enough difference in the performance and enough difference in the compression ratio. And I very strongly feel that, there is enough performance, at least 2x performance, and I see it internally, that can be gained out of ALP with things that we've built on top of that already sit in Arrow. So any further improvements that we think any other encoding might have, ALP is going to far exceed that performance with those improvements. And I think the spec, again, has been polished out enough that it's fairly expressive and fairly extendable. Micah, you had any points to add?
No, I mostly agree. I think there's like 1 or 2 points that we should just close on the doc, but I think it mostly looks good. The main thing is, like, once the spec is, like, once we feel comfortable that we aren't going to change the spec anymore, we'll need a Java implementation also. But I think this is very, very close. And I think Andrew, I think, said he was going to either try a prototype himself or find somebody to like prototype it in Rust. So we should yeah, like, I think unless people are like doubting the numbers, which I don't. I think both academic and the stuff we run internally seem like it's a substantial one.
Yeah. And like if you compare it with the numbers that I published like 2 or 3 months back, you'd see the decompression speed is 1/3 of what the numbers over there are. And that's primarily, as I think I discussed it with Julien when we met, primarily because of the bit unpacking. And if I can probably share the flame graph also, if I still have it, that's where the thing is. So that's why I'm very, very confident that with once this goes in and with the effort shifts towards that, we will have. I don't think any other encoding scheme right now will match the performance, especially for pseudodecimal.
Sounds good. So I think the next step would be probably if you can resolve the comments that have been integrated in the doc, right? Like whenever you had feedback, and I've seen I resolved at least one today. It's been integrated in the doc. You can resolve the comments thread, right? Or either updating in the spec, or if it goes as more commentary at the bottom of the doc, right? Like it's kind of things we explored or we discussed. And then once we have resolved all the comments, we can, I think we need to decide when we merged in the spec. So we have, you have the C++ implementation, right? There's a couple other implementation going. Do we want to do a vote to finalize the spec and say this is it? This is
yeah. We always have 2 implementations before we finalize the spec. And right now, the way that what we agreed to last time is Java and plus 1 other implementation is like what's needed, just because Java is still considered the reference implementation.
So we would want Java implementation like for this?
Yeah, I think so. I mean, we can discuss whether we still want to keep Java as the reference implementation, but I think Java still by far has the widest reach, at least for writing these things.
So we have a C++ implementation. We have maybe the beginning of a Rust one, right?
Yeah.
We
might be able to like take between the C++ implementation and the spec. I wouldn't be surprised if we could like get an LLM to like write Java, or at least like give a reasonable draft there. But
yeah. So the process would be, so we are very close to a finalized spec, like at least, on the like verbal agreement. And then as soon as we can have 2 implementation and cross-compatibility tests, we can have the vote and say, okay, like we validated the spec by having, cross-compatibility tests across 2 languages, and then that'd be it. Then it would be added.
So a quick question, like the C++ PR that sits out there, should it be like, let's say, this spec, after I've resolved all the comments, I've posted everything that's been discussed in the spec, then the only way to get traction on the C++ PR is after we have the Java PR and both get merged around the same time?
So the order would be, we have the spec PR up, that should unblock the reviews and like for C++, but generally we don't merge anything until we have like the 2 draft implementations and there's a formal vote showing we have compatibility. So like it can be reviewed and we can address any comments, and then it just might be a little bit of lead time before it gets merged to have the vote.
Got it. How would we get traction on the Java PR then? Like, do we have anyone who's like willing to do it, or
we can see if there's any volunteers. We might just want to reply to the mailing list asking if there's any volunteers who want to do Java, and if there isn't, then maybe we'll figure something out there. But let's see if there's any general volunteers from the community first.
Okay. I have enough experience in Java, as in case anyone doesn't vote for it, I can get started with that too, and someone can polish it then for like the latest Java spec. Yeah,
Alkis.
I have a low-level /spec question. Should I take it offline, or is that a good time?
Go ahead. If it takes too long, we can always take
okay. So in the spec we have exception handling, and it's kind of fixed. Could we open it so that a smart encoder can pick some outliers and put those exceptions so that it can do more efficient for packing?
I don't think there's anything in the spec that prevents that.
I mean, the way it reads is kind of very prescriptive, that these are the conditions, this is what goes as exceptions.
Yeah, so I think we should revise that. Because so in my mind, like the actual encoding thing is, here's a recommendation on how to encode, but I don't think.
I see.
Okay. But it's like, if you just want to do but we should clarify that. That's a very good point, that like, and the way that I suggested that this comes out in PR is like the writer implementation part of the spec like just goes to like implementation details, and the pure encoding part just describes the kind of the bit layout, so that a smart encoder could get better for encoding if you wanted to pick something there.
Yeah. So Alkis, like anything that goes in the exception vector can be an exception. You can choose anything. Right now it just picks a certain set of things, like not a number or very large set of values that don't sit in that do not well with the compression ratio, but you can pick anything.
Yeah. So we can clarify that.
Thanks.
Okay, so we'll have the current implementation, but the implementations, as long as they respect the format, they can pick any strategy they want to.
Yes.
Okay.
Cool. So action item for me is I'm gonna I think there are a few threads that have already been closed. I'll try to resolve the others and close it. Once that is done, I think there's a Parquet encoding format thing, the PR, the spec PR. I think Andrew Lamb started something. I can probably just push to that because the spec has evolved since then. And then we need to get someone from the Java to get it implemented.
Okay, yeah, and we can think we can hold like broadcast a bit the message that we're looking for volunteers for the Java implementation, and worst case scenario, we can have a first implementation. Right? You said you would do that, but I think we could probably find help here.
Okay, got it. Awesome. So yeah, I'll have things shown before the next meeting. Yeah, the spec part.
Yeah, thank you for driving this. I think it's yeah, it's great to see it happen, and there's been a lot back and forth. So
yeah, no, thanks a lot for the feedback. I think spec has evolved for better now.
Yeah, I think Andrew mentioned that he's had a chat with Peter Bonks at the conference. So, but I mean, we'll see where this goes. I don't know. It's just I got an email from him.
Nice.
Because he's at the conference, right? So they're kind of chatting about those things. So I'm sure he'll be able to share with you what they discussed.
Nice. Okay.
Okay. Do we want to go to the flat buffer footer? I think we put this. You wanted to hear about Rogue's progress.
But I don't see Rogue didn't join today.
No, Rogue is not here.
Yeah. So I think my main I did a first pass review on like the actual flat buffer thing in Parquet format, and it mostly looks good. I think most of the comments were about like we should have more documentation and like some naming bits. But we should I think one thing that's missing is like actually having CI so that we can like make sure the flat buffer thing compiles, and any changes to it will continue to compile in the central place. It's like a something that will eventually become a blocker. The C++ implementation is out. I haven't had a chance to review that. I don't know if has Antoine or anybody else given feedback on the C++ side of things yet.
No, but could we assign someone to do it, or is it kind of free for all and someone will take a look?
If you tag me on it, I will try to do a first pass. It's been a while since I've reviewed code there, but I can
awesome
then hopefully help out.
Okay. Anything else on this front?
Nope.
Okay.
Yeah, I put this on the agenda. I think enough people have reviewed the PR here. I'm going to send out one more reminder to the mailing list, see if anybody rejects, but then I will merge it. I don't think this needs a vote, but again, because it's really just clarifying kind of existing reference implementation behavior. But that's
yeah, I don't think this needs a vote. I think if it's the PR is approved, we're good.
Yeah. So I think we're probably on question about indexes.
Yeah, I think that came from Adrian.
Yeah, hi folks. I met some of you, but I'm Adrian. I work mostly in data fusion, and I'm a team lead on a system that does a bunch of stuff with Parquet files and distributed database type stuff. So one thing we've spent a lot of time on in our system is just external indexing of the data, and I find it an interesting topic because indexes are generally more forgiving than encodings and things and others changes like that, and they can also have the potential to do a lot of data skipping, right, and just not doing work is usually cheaper than doing more efficient work. And most systems, lake houses and whatnot that operate on Parquet files have some sort of external indexing. And another thing I found quite interesting is working with a lot of the newer formats, Vortex, those sorts of things. One of the things they do is they have more options for indexing. From my perspective, like Parquet files themselves currently only have like zone map or min-max indexes. That's essentially the only sort of like index, well, and boom filters, sorry, indexing information you can have in there. Andrew Lamb actually had some blog posts and work he did where he showed that you can embed essentially arbitrary bytes into a Parquet file, and then put some data in the footer to say, here's some arbitrary bytes that represent this type of index. So what I'm wondering is if other folks have done similar things where they've embedded arbitrary indexes. Like for us, we currently have external full text search indexes on some columns, and some other stuff like that. We were looking at adding like vector indexes, maybe embeddings, that sort of thing. And so I'm starting to think like, okay, if I'm going to start adding like multiple different types of arbitrary bytes and whatnot to Parquet files, is there any feedback from the community on doing that sort of thing? And two, is there an appetite for more working towards some sort of standardization on that? I recognize it'd be quite difficult to say here are the types of indexes and they're all standardized, but I think that the good thing is you don't need strong standardization in the sense that, hey, if you write some index information in there, old readers don't support it, no big deal. They just can't. They can just not use it, right? So it's kind of much more optional in my mind.
Yeah. So I think my first feedback on this is you can experiment and have numbers. I think you can first prove the value to you, right, into your use cases.
Sure.
And then this is something you can always share, right? Like, and then you've seen the discussion around the ALP. Then the discussion, is it adding the compatibility to the format? Is it worth it from a performance improvement perspective, right? Like, so on ALP, we're at the point, right, well, we need some validation with some existing public data sets, and we have some good confidence that the value of the performance improvement is worth adding the complexity to the format. So the same thinking would be applied, right? So if the advantage of being able to embedding arbitrary indices in file format allows you to easily verify the value, right? It's kind of get some numbers and depending on some queries and so on. So I think then I would recommend when you do something like that, you can share about it, right? And you could also either in this meeting or blogging about it, and I think that would stimulate the conversation on the next step of would there be interest in standardizing some of those.
Yeah, to add on, I think it'd be great to maybe standardize some of these because they do come up. I think one of the things in the past is like people like propose random indexes, and like I think the main blocker is there hasn't been an appetite to like show that they integrate well with like engines. But if you're like doing work across Data Fusion and Parquet anyways, that takes out like I think one blocker to say like, hey, we have this index, Data Fusion can use it to improve performance by X, and like I said, like if we have some benchmark data sets, that's good. It could be that like indexes lend themselves more to a like pluggable model where like it could be that we want like another way of thinking about it is like standardizing it and get indexed in Data Fusion, and then like if we have a standard way of standard bit of metadata saying like, look at this metadata, this is how Data Fusion does it. It could be standardized at that level, but it would be great if we could also push it down to Parquet, I guess, as well as like, so like bifurcated.
100%. Like in my mind, is the kind of thing where it's like first has to happen in like, I don't know, my system. Then I can go to Data Fusion and say like, hey, I have, some appetite for standardizing this. So other Data Fusion, Data Fusion CLI and other things like that can use some of these indexes. And then after that comes like saying like, hey, should we have some sort of pluggable thing at the Parquet level. And yeah, to your point, I think what's interesting is you can do pluggable type stuff, right? You don't need to say like these are the types of indexes. Even just saying like, here's how you format the metadata to say that, here's the type of index, here's the bytes it represents, or something like that is already, helpful.
Yeah, I mean, but in the long run, I think standardization is great, and I think it helps everyone. Like it'd be like if they like, but where that like it'd be good if it was like governed and documented someplace so that's fixed and like people can rely on it. If Parquet is too heavy of a lift, ideally we could fix that, but we should figure out Alkis.
So we added the extension mechanism last year. So I think that's kind of a great way to plug it in. And then you can say, this is my UUID, this is the extension, it's stashed, the metadata is stashed in this part of the footer, and then this blob is specified like that, and this is the index. And my hope with that, different companies will publish different indexes, and then we can compare them here and say which one should we standardize. Is there anything that is better than the rest, and we make it a standard.
Yeah, sounds good.
Also, maybe it's not the best. Maybe you published it first and it got a lot of other users, and then there's push to standardization, even if it's not state of the art.
Yeah. Either way, like, yeah, I think it'd be great to have work on indexes also in my mind, and just like we can see if the process that we're using for encodings makes sense, or if there's an alternate process, like it can be worth discussing that as well. Like, we want to make sure that we're like maintaining compatibility, and like if we're standardizing something, it's worth standardizing, but like maybe we only need one implementation of the index to show its worth, instead of having it like the standard 2 implementations or something, or just pluggable. But
yeah, I agree. Like indices are little, have a slightly lower standard of validation, because it's kind of, they don't break compatibility. Like when we support encoding, we have to support it forever, right? And it's just like more optional features, have more flexibility, like you said earlier.
Yeah, makes total sense. Thanks for the discussion.
is there anything else you were hoping to get out of it, or just
No, just ask some smart people things in my mind.
So I think, yeah, if you end up working more on that, I think we'd be very happy to hear about your experiments and what you're doing in this forum, right? That we get a great place to share and get feedback and see if others are interested for those specific indices and things like that.
Yeah, awesome. Yeah, I mean, the thing I've wanted to do for a while in our system and just haven't gotten around to it is like embedding our full text search indexes into the Parquet files themselves to save a object store write mainly. And it's just not a high priority. I haven't gone to it, but when I get to it, I think that'll be my first test case, because I can like feature flag it and whatnot. It's not a standard data set, but it's easier to justify at work.
So just based on some of the experience working on these things, I think indexes, especially for I definitely see use cases for these inverted indexes, and definitely the full text search indexes that you mentioned, and they really help speeding up a bunch of queries. And I think they're probably, as Julian pointed out or Micah pointed it out, there's just so many different ways to specify those and lay them out. It would be really, really helpful if you can, bring in some motivation that these are the kinds of workloads which benefit with these indexes, and, spec out what kind of information that should be present in those indexes. And then we standardize the information, and then the layout would really help move things in that direction. And in just my view, we don't really need to be, restricted to every data file having index, like an index suffix to it. one can also go in the direction of index files, which like a Parquet file which just has indexes, and then you can link it like the way deletion vectors or the buffin files work out. So bringing in motivation, and then that the kind of workloads that help with it will really move the needle.
Yep. Thank you.
So that's another. Yeah, so that's another reason why I think
Okay, do we? So we reached the end of the topics for today, which means that I did a great job at time management. Do we have anything else we wanted to chat about, or otherwise we can end the meeting a little earlier? Okay. Well, so we have a few to-dos, right? Like Prateek is going to resolve a bunch of comments and work on finalizing the spec. We'll look for volunteers for the Java implementation if people are interested. And there's some reviews on the flat buffer side of things. Oh yeah, and the file path clarification. So if people want to comment, they should do soon, and Micah will merge them. So those are the to-dos for today. Okay.
Yeah.
Well, we'll see you next time, and have a great rest of your day. Bye-bye.